One of the best ways to analyze data is to look at it graphically. A proper scientific graph can tell us a lot about a data set that we might not be able to see just looking at the numbers. This video explains how to plot data in an online program called Plotly and add custom error bars to those data. So these are the error bars that surround each data point, and it gives us a way of showing the uncertainty in our data on the graph itself. And it immediately tells the reader of a report how certain each data point is, which is great. Let's go to our objectives. After this lesson, you should be able to use Google Sheets to calculate the mean, standard deviation, and standard error of a data set. Import your data into Plotly and graph it, including the error bars, and copy your resulting graph back into a document or other program, for example, Google Docs for your lab reports. Okay, the first thing we need to talk about is a number called the standard deviation. And we use this Greek letter sigma to represent the standard deviation. And so what is it? It's a number that measures how spread out a data set is. So I could take a bunch of trials and maybe they would all be really, really close together, or maybe they might be really, really spread apart. In a previous video, we talked about random error and how it can spread out a set of data from each other so that it's not very consistent. And that kind of data where there's a lot of random error and it's very spread out means that we might have a high standard deviation. That's one example of a scenario where we might have a high standard deviation in a data set. What does it physically mean? This statement might be a little bit hard to understand at first, but I think it'll make more sense with an example, so just bear with me. So statistically, roughly 2/3 or 68% of all trials will fall within one standard deviation of the mean. And the mean is what we commonly call the average. You add up all the values and you divide it by the number of values you have. And if you sort of take a random measurement every time, it's 68% of the time you would expect that that measurement is going to fall within plus or minus one standard deviation of that average. Almost all the values, 95%, statistically are going to fall within two standard deviations. So let's do an example here. So let's say the temperature of a room is measured multiple times. I have my thermometer or thermocouple or temperature probe, and I take a bunch of measurements, and the average of all of these measurements is 65.0 degrees Fahrenheit. And I also calculate the standard deviation to be 0.02 degrees Fahrenheit. If that's what the standard deviation of the data set is, then physically what this means is when we measure the temperature under these conditions, then 68% of the time we would expect to get a value between 64.8 and 65.2 degrees Fahrenheit. So plus or minus 0.2 degrees Fahrenheit, which is the standard deviation of that data set. If I wanted to show even more confidence of where my mean is going to be, I could expand it out to two standard deviations away from the average and make a claim that 95% of the time I would find a measurement within that range. So when we measure temperature, 95% of the time we expect to get a value between two standard deviations away from the mean. So if one standard deviation is 0.2 degrees Fahrenheit, then I need to go minus 0.4 degrees Fahrenheit, which is 64.6. And on the upper end, I could go as high as 0.4 degrees Fahrenheit above the mean. So that's 65.4 degrees Fahrenheit. Okay, so this is kind of what standard deviation is telling us about a data set. It tells us how spread out is a random measurement going to be from the mean. A different kind of way of quantifying our uncertainty is called the standard error, and we just abbreviate that SE. And it's a measure of how our uncertainty of the true value improves with an increased number of samples. And we use this basically when we don't really know what the real or true value is. I don't know the actual temperature in the room because I can't measure it exactly. But I can improve my my understanding of what the temperature is, my inference of what the temperature is, by making many measurements. And I increase my confidence in my measurement when I increase the number of samples. So the standard error is going to be the standard deviation, which is what we talked about in the previous slide, and I'm going to divide that by the square root of the number of samples. So you can see that as I increase my number of samples, if I were to measure something over and over and over and over again to get a lot of samples, the denominator is going to get bigger, which means that the standard error is going to get smaller. I would drive down my standard error by increasing the number of trials. And this kind of makes sense if you think about how we do labs in physics. Sometimes, let's say we want to take a time measurement, and we can't measure time exactly using our timer. So we know that, and we're going to go and we're going to take multiple trials. We might take 3, 4, 5, 6, 7 different measurements at the same time, and then average them together. And this would be a way of quantifying, well, how much uncertainty do we have in that measurement? That's at least due to random error. Okay, so let's take a look at some steps as to how to do this. And I'm going to be going through an actual example of this data in a moment. So you can write down these steps or make note of them, and then we're going to apply them right after this slide. So step number 1, enter your independent variable and all trials for the dependent variable into a Google Sheet. And for each set of trials, you're going to do a couple of functions in Google Sheets. You're going to use the function average in order to find the mean. You're going to use the function standard deviation, or STDEV, to find the standard deviation. And you're going to divide the standard deviation by the square root of the number of trials to find the standard error. Once you have those error values, we're going to enter your independent variable, dependent variable, and standard error values into Plotly, which is this great online program that lets you make beautiful graphs. And we're going to graph it using a scatter plot. So let's see how that works with some real data. So I'm going to change my screen over to Google Sheets, which has some example data from a pendulum lab that I did. One of my students, you can follow the link in Edmodo to this spreadsheet of my data and go up to File, Make a Copy. You can make your own copy of this data and follow along as I go. Remember that this is a video, so you can pause and rewind anytime you feel like it, if you feel like I'm going too fast. So just try and follow along with what I'm doing. So here's the data that I recorded in my pendulum experiment. I tried 10, 15, 20, and 25 centimeters of length, and then for each length of string, I swung it back and forth, and I measured the time that it took to swing back and forth, and that's called the period. So I measured that once, twice, 3 times for each length, and then on down below. I did that for the 4 other lengths. So now I'm going to just follow through my steps that I had in our notes. I've done step 1. I've entered my independent variable and all trials for the dependent variable into a Google Sheet. I'm now going to find the average, standard deviation, and the standard error of that data set. So let's see how I do that. So my next column over, I'm going to just make a new column over here, and I want this to be the mean. I want it to be the average. So I'm going to define T average, let's say, and the units are also seconds. I'm going to press the equal sign, and the equal sign tells Google Sheets that I want it to do a calculation for me. I'm going to give it some instructions that does a calculation. What I want to do is calculate the average. So I type in average, open parentheses, and what we're going to put in parentheses is the values that we want to take the average of. So I want to take the average of these 3 values. So you see how the cells B3 through D3 appear right there for me. And I can close the parentheses and then press enter. And there it is, voila, it's calculated the average for me. I could type that same thing in on all these cells, but actually I'm a little bit lazier than that. I'm going to use a really convenient thing. If you see this square in the bottom right of the cell, that means you can drag the formula. I'm just going to click and drag the formula down through all rows, and boom, it has calculated the average for each row on these three time values for each length, which is pretty cool. The next thing I need to do is find the standard deviation. So I'm going to call it standard deviation, just abbreviated, of these values. I'm going to press equal again because I'm telling Google Sheets that I want to calculate something. I'm going to type in stdev, open parentheses, and once again it wants me to put in what values do you want the standard deviation of. Here's my data set again, T1, T2, and T3. Take the standard deviation of my data set. And I close parentheses and press enter. There's the standard deviation, which is actually pretty high. I mean, we're looking at about 1/6 of my mean value. I like to think I'm pretty quick with the timer, but as you all know, timing things, especially quick oscillations that are a fraction of a second, it can be pretty difficult to get consistent results, which is why we take multiple measurements. So once again, I'm going to click and drag that formula down, calculates the standard deviation for each row. And then my last column, I want to make the standard error. So let's type in standard error just to give me some sort of heading. And once again, equal sign, telling Google Sheets that I want to calculate something. And this time, there's no actual function for standard error. You might think it would be STERR or something like that, but there actually isn't one. So I can just manually give it the formula that I want. I want the standard deviation, which is over here, and I want to divide that, I'll do the slash, divided by the square root, SQRT, of the total number of measurements that I have. I took 3 measurements for this data set, so I want to divide the standard deviation by the square root of 3. That is my n. That is the number of samples I took for this data set. And I'm going to press enter, and there's the standard error. And once again, drag that down. And now I have calculated the mean, the standard deviation, and the standard error very quickly for my data over here. Okay, so next step, I'm going to enter my independent variable, dependent variable, and standard error values into Plotly and graph using a scatter plot. Let's see how that works. So I'm going to go over to plot.ly, and if you don't have an account yet, you can get a free one by going to sign up over here. You can create an account. If you already do have an account, you can sign in. So mrratphysics@gmail.com. And I can sign in, and once you sign in, it actually gives you this really cool feed of really awesome data. Number of people with at least $1 million of investable assets. I mean, you know, this is all just, I mean, obviously all this is not physics, but it is very interesting data of graphs that people make of various things. So you can browse through that if you'd like to nerd out. Getting right to our point, I want to be able to make my new plot. So I'm going to go to Workspace, and it's going to load me a workspace. And you can see I've actually done this once to test and make sure it worked. So I'm actually going to delete those because I'm going to start from scratch and show you how to make these plots. So here's my workspace. What I'm going to do is go up here to New Grid, and that's going to let me define a lot of data. And you get this kind of spreadsheet looking set of grids. I'm going to go back to my data now. All I want is the independent variable, the dependent variable, and my error. So my independent variable was length. I'm going to highlight those, copy it back to Plotly, and I'm going to put that here in my column 1 choose as X. I want that to be the X-axis. Over here I want a Y-axis. I'm going to take my average times for each string length. Remember, this is the period. This is the average time it took for the pendulum to swing back and forth for each of those string lengths. I'm going to copy that data, put it over here into Plotly. And I have that already as choose as Y. And you see over here where we have error bars under options. I do want to add error bars. So if I click that, you can see it gives me these options. Can I add an error in the X direction? Can I add an error in the Y direction? I'm going to go back here and copy my standard error, which is what I'm going to use for error. Paste that in the third column, and I'm going to choose that as the error on my Y-axis. Okay, these values represent the error, my error bars for what I have measured on the Y-axis, which is time. Okay, so once I have my data in here, I'm going to click Make a Plot. And this particular data calls for a scatter plot. Later on in the year, we'll be talking about how to do all these other graphs and why you might want to do those other graphs. But in this case, let's do a scatter plot. And over here, insert into, make a new plot. We're just going to click scatter plot over here. And check this out. We have our 4 data points with error bars that are surrounding them. And what we're going to do is make this a proper scientific graph. I need to do several things. Let's add a descriptive title. How about effect of string length on period of oscillation for my pendulum. Over here on the y-axis, let's label it. My y-axis is period, and I want to include the units, seconds. On the x-axis, I just need to click it, and I can type in string length in meters. And notice that these graphs do not, the axes do not begin at 0. We want, in our class, we want to make sure that we're beginning our axes at 0 so that we can see what the overall trend is. So right here on this point 1, at the end of the x-axis, I'm just going to click that and manually type in 0. It's going to force it to begin at 0. And over here, I'm going to click on the y-axis, so it shows me a value. I'm going to press 0, or type in 0 so that I can force the y-axis to begin at 0. And here's my data like so. Some data is going to call for a trend line. I can do fit data up here. If we want to add a line of best fit, we can add a fit to this trace. Linear is fine, for now at least. And we run this fit, and you can see here's my line of best fit. I can hover over it and see the values at any particular point in the line, and here are my data points right here. 0.84 seconds plus or minus 0.03 seconds. I've now shown on my graph what is the uncertainty, what is the error in each of these points. Okay, and you can see that the uncertainty is not actually constant for these points either. The uncertainty over here for the shorter string was actually much higher than the next one up. The uncertainty here is much tighter. The error bars are much tighter here, showing that I was much more consistent with my measurements on this trial for 15 centimeters than I was with 10 centimeters. Okay, so there's a lot we can do here. The last step is I'm going to save this in my worksheet. I'm just going to save the file, and I don't want to share this, but if you want to tweet out your graph, go for it. The last step is I need to export this to an image file. So I click export, which is right here, and it gives me this dialog: download, export. A PNG file is just fine. Just the default is all fine here. And I'm going to download. And you should see your your image file appear down here in your downloads. And what you can do is just click and drag that over to a lab report. So here's a lab report template that you are very familiar with, I hope. And if I want to drag a graph here, I can just drag it here. And here is my graph embedded in my lab report. Obviously, if you want to put this into any other program, such as Google presentation or PowerPoint or any other sort of file, you can do the same thing. Just insert the graph file wherever you want it, and there you have it. Let's go back to our presentation. So right now you should be able to use Google Sheets to calculate the mean, standard deviation, and standard error of a data set. Import your data into Plotly and graph it, including error bars, just practice, and copy your resulting graph back to a document or other program.